Okay, fantastic. Well, I'm a little bit of housekeeping for everybody. So first of all, thanks everybody for joining us today. It's really good to see this really healthy number of attendees listening to this webinar about fire stopping. I'm Isaac from Solibri. I'm accompanied by, I've got a few guys at Ridge and Partners who will introduce themselves shortly, Mike, Brent and Alex. And I've got Simon Gilbert, who's our Technical Services Manager here at Solibri, going to do a short presentation on the subject of today as well. So for those of you that may have questions as we go through, we are going to host a Q&A session at the end of this for a good 5-10 minutes. So if you have any questions, then feel free to pop them in either the chat window, or if they're specific to a person or you just like to position them as a question privately, you can do so both publicly and privately in the question box. We are going to host a very quick poll at the end of this webinar as well, and I'm just going to kick things off by introducing you to today's session and talking a little bit about Solibri before I hand over to Ridge and Partners. So again, thanks everybody for joining us. Let's get going. So welcome to what is a part of the Fringe series, Digital Construction Week webinar series. And today's session is co-hosted with Ridge and Partners, who will be doing a presentation as mentioned. We're going to have a brief introduction from us, a couple of presentations, and then that Q&A session. This webinar will be recorded and it's going to last approximately an hour long. And as mentioned before, and for those that are still joining, any questions, just throw them in that question box and we'll get to those at the end of the webinar. So a bit of background on Solibri for those that aren't aware. We're a Finnish company headquartered in Helsinki. Our priority in this world is all about quality assurance, to become the de facto standard and to maintain that level for quality assurance and quality control in the construction industry. And just talking to the UK arm. So let's just take a minute to look at where BIM's at. So we understand its maturity and where BIM is coming along. We understand that the actual benefits of BIM are becoming more and more recognized on a very daily basis. We're generating things like more files. We've got local standards and mandates that we're understanding. But really, when it comes to quality and Solibri at the moment, we see there's a need for high quality information. We can see that quality assurance and quality control is more than just design coordination and clash detection. For those of you that are using Solibri and utilizing rule sets, classifications, will understand and have seen the benefits of exactly what there is, whether it's fire stopping, egress analysis. Simon's going to talk a little bit later about sort of the big picture on rules as a general, sort of consensus, but also go into some detail on what these rules are all about that we're discussing today. Awareness of problems throughout the life cycle of build, and I'm going to talk a little bit about the cost of issues and when to resolve them and why it's best to do it at the earlier stages. But naturally, big buzzwords like interoperability, a huge focus point for Solibri this year has been all around opening up our tool to be available within others and making sure that Solibri is massive endorsers of OpenBIM, which I'm sure a lot of you are aware, using file formats like IFC, BCF and COBie. So we know this already. When we're referring to things like quality, we understand the importance of both time, money and scope as huge factors towards improving our standards and improving our workflows and processes surrounding quality. And we're going to get into a little bit more detail on how we break that down today. Here's a bit of research on the actual cost of fixing a mistake at different design phases. So at the design phase, we can see that the cost is incredibly minimal. But as we work our way through the life cycle of a project, you can see here that fixing a mistake costs more and more, tenfold more. So if we actually prioritize our workflows at the design phase to fix issues, then we're going to save ourselves a lot of money. And that is also represented in the amount of waste that is in the construction industry from both rework, as you can see, 30%, 10% materials are wasted, 10% of projects are over budget. So prioritizing our communication and our planning towards our projects is really, really important. So I've got a very quick video just to give you another sort of introduction into Solibri. It's only a minute long. I am going to turn the volume down though, because I've been told it's a little bit loud, so just bear with me a second.
From office to site, owners to subcontractors, Solibri offers full workflow support to all your construction projects. In the office, Solibri is your gatekeeper for quality, combining all the different models into one to perform highly advanced checks on them and to make collaboration between all the involved parties effortless. On site, the same information is seamlessly available for site managers, along with taking up the needed quantities and other information from the model. For the subcontractors and other involved parties, Solibri allows all stakeholders to view the model anywhere, anytime, and get the information they need to get their job done. Give everyone in your project the right tool for the right job, and start your journey to quality with Solibri.
Perfect. Hopefully that was the appropriate volume for everybody there. So now what I'm going to do is just break into a little bit behind the workflow of Solibri Office to share with those that aren't particularly aware of where the rule sets sort of sit into the workflow, just so you can see what Solibri Office as a product has to offer. So we know we've mentioned IFC imports already. We're going to create our Solibri project using file formats such as SMC for our both individual IFC imports and our federated models for combining IFCs together. We can visualize, we can navigate, we can look at the coordination of those models. We can identify things and components and spaces by using our tools such as classifications. And classifications are, in effect, can be a huge prerequisite for checking and using the rule sets, because they really help to enable you to run effective rules by making sure that you know what sort of components you are checking against. So within the checking environment, we've got tools such as model revision comparisons. We've got over 50 rule templates that come out of the box with Solibri that can be defined and tailored to your projects. But the real core of those rules are to identify problems and make decisions on the importance of those problems, which will based on severity. And that's encapsulating the sort of introductory level of Solibri through to being able to identify problems, a huge core part of Solibri. But once we've found those problems, we're going to want to communicate them. So within the communication area, we've got tools such as BCF Live Connector, which enable us to integrate with issue management systems on the cloud. We can export those BCFs out if we want to, and share both Excel reports, BCFs, and communicate with people the issues and the challenges that we found from our checking results. But the functionality that we're talking about today are new rule set templates to do with egress analysis and fire-stopping rules, which is the exciting demonstration and presentation Simon's going to do in a little while, which is the way in which we can more intelligently and deeply find potential issues with fire-stopping. And it's only once we've managed to locate these problems, fix these problems, can we really start to do information takeoffs, deliver COBE, deliver our models, and understand that that information is reliable and fit for purpose. So that's the bigger picture on the Solibri Office workflow, which we'll get into a little bit later on today. But from that point onwards, that's me. I'm going to hand over to Ridge Partners now to do their part of the presentation. I'll just share my screen with Mike. One moment. Perfect. Over to you.
Thank you, Isaac. So I'll just wait until I can start to see my screen. Thank you very much, Mike. So we're going to talk a little bit today about fire stopping and using digital technology to make the right decisions. So you'll see littered through this presentation, there are a few QR codes that you can use to access various bits of information. So for those that aren't aware, Ridge Partners, we're a multidisciplinary property and construction consultancy. We have over 600 employees spread across 12 UK offices, and we pride ourselves on 80% repeat business, and we're 75 years old this year. So today, my name's Brent Rees, and I'm a partner with the business, and I lead the digital engineering team. I'm going to talk a little bit about the basics of fire stopping and why it's such a challenge in the construction industry. Then Alex, who's a team manager within the team, is going to talk through how we use Solibri to mitigate some of these challenges. And then Mike, who leads some of the digital engineering activities across the business, across our multidisciplinary organization, is going to talk about the benefits for clients and how we might repurpose that for existing buildings. So a little bit more about digital engineering and our consultancy services. We provide services on projects up and down the country for a mixture of end clients and contractors and other consultants in the industry. We do a lot of work in the information management space, and it's something that Alex particularly specializes in, using tools like Solibri. So the development of requirements and support in the delivery of COBE on projects. Similarly, BIM coordination, another key activity for us, and we do a lot of that for main contractors, where we again utilize tools like Solibri to identify issues on projects and report those back to the team. Firestop compliance review. So a little bit of what we're talking about today is about using models to better design, specify, and utilize information for fire stopping. We'll touch on that a little bit more. 4D planning, so the use of tools to bring models and projects to life against construction programs and simulate the sequence of that going together. And the final piece about digital facilities management and consultation in that space to allow clients to make better decisions and use tools to better manage their buildings in a more efficient manner. So Alex and I did a presentation not dissimilar to this earlier this year, in May this year. That can be accessed through this QR code, is available to watch on YouTube. We'll touch on some of the same points, but expand on those as well through this. So fire stopping, the golden thread. So for my section, if we move on to the next slide. So to recap on some of the basic terminology. So in projects, we'll have a number of openings in walls to allow services to pass through, and commonly referred to as builders' work openings. In order to maintain the performance, the fire rating resisting performance of that wall or floor, that opening needs to be filled with a fire stop. So we'll make reference to both of these as we step through. A key part of what we're going to show you is related to service penetrations through that builders' work opening and through that fire stop. Because that influences the design and specification of the fire stop. Service spacing, so the gap between the services that penetrate that fire stop is a really important criteria in that, as is the aperture spacing, so the gap from the service to the edge of the builder's work opening is shown in that diagram. So fire stopping generally, I mean, anyone who's worked on a construction project will probably sympathise that fire stopping is a notoriously complex and often difficult package to design and get right, because of inputs required from lots of different parties. What really needs to happen is there needs to be better clarity on who actually leads in the design and specification of those, as well as builders' work openings and any dampers that might be applicable to any ducts passing through that. There's also complications around PI. The PI market is a notoriously difficult place at the moment, and is the PI of a lead designer adequate for them to carry out fire stop design and specification? And then looking across into construction operation, the process of installing these and then managing those through operation again is a notoriously difficult aspect of fire stopping. Next slide, please. Add to that approved document B of the building regulations has always had a line within it that any proprietary sealing system, i.e. a fire stop, needs to be shown by test to maintain the fire resistance of the wall, floor or cavity barrier, meaning that if you have a fire stop in a builder's work opening and a configuration of surfaces penetrating that configuration needs to be shown by test to perform for the required time period. The difficulty with this is that only a finite number of scenarios have been tested. So there's a rule for different types of materials of services passing through a fire stop, which need to be understood and applied to the specification of a fire stop. On top of that, I mean, I touched on the multi-party process that is kind of fire stop design specification. I mean, with regards to this scenario, you would have one party that would ordinarily design the partition and the opening within it, and another party that constructs it. It would be another party that would design the services, the service distribution, and then another party would install them and the spaces accordingly. And then it would be another party that specifies the fire stop and installs the fire stop. Add to that then that the client then has a duty to maintain that through operation and understand the decisions that were made through design, and that kind of further highlights the complexity of the situation. Add to that a few years ago the Grenfell disaster has now brought renewed focus on design and specification of materials generally, and so whilst that wasn't directly attributable to fire stops, it's clearly a key aspect of fire design in buildings. A spin out from the Grenfell disaster was the Hackett report, which made some pretty stark recommendations about the state of the industry and aspects that needed to change in order to give residents a safer place to live. And if we go on to the next slide, a key component of what's come out of this is the golden thread, which is a recommendation from the Hackett report, which recommends the adoption of digital and BIM processes in order to better deliver information to the clients at the end so they can better manage information about the building through operation. And I won't touch too much more on that because I'll pass over to Alex.
Thank you, Brent. So I think you set out some of the issues that happen with fire stopping. So let's have a look at the digital approach that we've developed to try and alleviate some of these. So this brings us back to 2015, before my time at Ridge. Fun fact, 6 years ago, isn't that scary? To the first project where we worked on to develop these rule sets and how we went on about it. So the photos you're seeing here are from the MVH project, which is a Jaguar Land Rover project. And a lot of the design was focused on precast concrete. And this meant that a lot of the openings and fire stops had to be designed before they went to site and had to be incorporated into the structure to make sure that it was still integral. And this was for Lang O'Rourke on the project. And this meant that the Solibri rules that we used to see how big the openings were going to be, whether the distances between the components were right. And you can see a couple of Solibri screenshots in the bottom. But it meant that the multi-disc design team were able to talk through some of the issues, and there was some give and take between the distances between services and the size of the openings and that sort of like. And as you can see from the bottom right, we won various industry awards for this design and process. Thanks, Mike. So this is the process. It's an iterative process, much like BIM coordination. You don't put the rules in, run them, produce a report, and then job done. There's always some checking to see if things have been closed out. There's some comments on the issues to see if somebody has to change something and then somebody has to follow suit. This fire stopping appliance is absolutely the same. So a lot of it will be multidisciplinary in terms of how big the openings are, how big the spaces are going to be, where the whole main runs will have to move to make sure that it's compliant. A lot of this is best done in a BCF tracking platform, and comments can be made. But as you can see from the process diagram, it's about federating the models, analyzing it's got the right information in there, analyzing the size of the openings, the distances of the services, the distances between the services and the edge of the openings, reporting these as issues, and then eventually scheduling these out so that it can be improved on site. And it's really important, one of those bullets on there is that these rule sets are aligned to real manufacturers' products and real test data for the information that will give the value. So who's this relevant to? A common misconception will be that it's only relevant to high-rise residential buildings, where it's not only relevant to all residential buildings, but most buildings it would be relevant to. There's fire stops in most buildings, there's fire compartmentation in most buildings, and this really should be something that is looked at and done, and something Brent highlighted there on most buildings. It'll be useful for designers. I think fire stopping is one where you might hear audible groans from designers when it's mentioned, because it's left out of scope. It's quite a grey area of who should be doing what, and it's not always something that is done well and is something left to the last minute, and you end up with changes on site. So getting a better design, improving set roles of who's doing what, will also improve professional indemnity insurance, PI insurance. It's useful to contractors to reducing risk on site and for the buildings that they deliver, but also through pricing. So if all of the openings are designed, the sizes are known, the product manufacturer has been chosen, then the contractor will know how costly it will be to procure the fire stopping products, how costly it will be to actually install them, and it will reduce risk for when they're tendering and for their price, and also for when they're tendering for maybe an M&E design to an M&E subcontractor package. Clients will benefit from this as well. They'll probably have a safer building. They'll have some really good data, which is something Mike will talk about in terms of when they're maintaining their building and any future changes they make. You know, buildings stay around for a long time and they don't remain the same. So there's always changes being made, walls being knocked down, moved into one, services being swapped out. So it's really important to have good quality data and see matching that up to the test data at the time. And lastly, as an occupant, we all want safer buildings. We all want to live, work, and be in safer buildings, and so it benefits us all to use this process and have safer buildings. So what level of information need is required within our models? Is this something that we can only do on 1% of projects, on all projects? And what do we need to get it going? So we do need to embed some data into these models, and it does have to be structured correctly. So for us to have a process that isn't just project specific and we can use on multiple projects with very different sizes of projects as well, we need to just include some very basic information all aligned to the IFC schema. So the first piece of information we'll need is a relevant IFC class. Much of the test data is relevant to whether it's a pipe or a duct or a cable tray or a piece of trunking or a ladder. And so it's really important that we have that information in there. And when you click on something in the model, it knows what sort of model element it is. And this links to the data. So the second point in there is the fire ratings need to be included on key model elements like walls, floors, coverings, so that we can start to match up with the test data of what's needed. And if the right IFC class isn't assigned, so if it doesn't know it's a wall, then it will not know to export the fire rating out of the native modeling environment, which for a lot of us is Revit. It's really important that in Solibri we're checking for the quality of the data as well. As you can see from that screenshot, it says 60 minutes. I suspect you will have seen, if you've had a look at models, then sometimes you'll get a 60 in that parameter, sometimes it'll be 60 min, sometimes it'll be 60 minutes, sometimes it'll be 60/60 to be mixture of integrity and insulation. We have to define these through an EIR, and so it's not just about this process, it's not just about coordination, it's about setting out what are our exchange information requirements, trickling that down to a BIM execution plan, and having a robust process for checking that this information is in there before we start reviewing the spaces of services, and even things like putting a 0 in for when it's not a fire rated wall will improve things, because then you'll know that it's not just been missed, there's been some conscious thought about whether it's a fire rated wall or not. M&E services will need to include material data. So some of the test data, including the rock wall test data, says we'll have different measurements depending on whether it's a steel pipe, a plastic pipe, or a copper pipe. And so that will need to be baked into the data within Revit and then onto the IFC export. And something that's key is to make sure that whenever we are putting data in, be it material or fire rating or anything else, that this data is also being seen in 2D deliverables. So it would be an absolute disaster to have a fire strategy drawing showing fire compartmentation, which is reading a different parameter to the fire rating parameter that you're then testing it against in the modeling environment. So consistency of this data and the structure of it is really key. One of the things that will have to be done is picking a fire stop product manufacturer and then shortlisting products within their lineup to align the test data. You can see there on the left is some samplings of some Firestop product manufacturers, and on the right you can see a little snippet of the rock wall test data where it's showing it's not only native to the different types of services and the walls that they're running through, but also which product is being used, and the distances that are acceptable between the services will differ between those. So it's definitely a must that this is chosen, and that the rules are based off of something that's real and tested. Modeling of builders works and fire stops. This doesn't necessarily have to go straight away. I mean, you can test the distances between the services before you do that, but ultimately a lot of these services will be put into these sort of letterbox openings, and the arrangement of these services will have to be reviewed and set out, and the distances between the services and the edge of the opening will have to be measured. So at a certain point in the process, it's really important to model these builders works and fire stops and start to put in what Firestop product has been chosen, who the manufacturer is, and then that will bake into what Mike will talk about later in terms of itemizing these, and then what an owner operator does with these is in terms of on-site checking. What are our outputs? So this is the last thing I'll talk about. We will have the most important part is the compliant design, and once you have that compliant design, this will be seen through the drawings, and you could also use augmented reality to compare what's been set out on site and what was in the model. This can also be laser scanned, so you can get dimensionally accurate comparison between the models, and if you wanted to, you could model up that laser scan and shove it back through Solibri and check that it's still compliant, even if it might not be slightly different to what the original design was. And you can also asset tag things, so you have a physical tag on site that a owner operator could scan and to make sure that you're picking the right one for the data. And this data can be fed into a schedule like you can see in the middle of the page with some images from the model, and then compared with an image on site to make sure that it's all signed off correctly. And it can also be in a COBie data set, which will help build into the jobs tab of the COBie data set, so you can make sure that these are being looked at regularly and to make sure they're not degrading, or new services haven't been poked through these fire seals. So that's my bit over. I'll hand you over to Mike.
Hello, everyone. Well, I last saw these slides before I was working at Ridge, when I was in a client organization at a university as a BIM manager there. And the first thing that sprang to my mind is how many sort of day-to-day running problems that this sort of methodology could fix once it's met handover. So the question I'm asking is, can we take this robust process for fire compliance checking of design information and apply it within existing buildings? So why would we want to do this? So 2 out of 3 of today's buildings are still going to be here in 2040. So as problems go, like the construction process is only going to fix 1/3 of the overall kind of issue. So we've got this responsibility to ensure that the buildings are safe. And we know if we're going to try and check all of these builders' works openings manually within buildings to make sure that they're compliant, that's going to be a really hard process. And then the other issue adding to that is that as buildings change over time, we'll see that small works contractors and things might not have considered fire stopping as they've put new services into buildings. So we've probably got sort of the situation that our fire compartmentation lines could be breached. So the question is, shouldn't we use all of these digital tools that are at our disposal to solve the holistic problem? So what benefits is that going to bring to building owners? Obviously, like life safety is the most critical of these issues, but then also things like the protection of property, the ability to reduce insurance premiums, ensuring that we're compliant with legislation. And I don't think there's anything quite as bad for someone's reputation as their building burning down or something like that. So just, what this could do for reputation is also worth considering in that mix. So what are the challenges? So obviously, like Alex and Brent have done a great job of outlining what this process looks like. But what changes when we move into existing buildings is that the data is bad. So during construction, we've got this availability of lots of information. As we look at an existing building, that's not there anymore. So there are a few things that we need to do. So first of all, do we have a fire compartmentation plan or any information on where the fire compartmentation lines are within the building? If we don't, we might need to go and do a survey to understand what the fire compartmentation should be within the building. The next thing is record information. So you could see from the process that's been outlined that we need to know what the fire stopping material is, and we need to know what the service types are that are running through that fire barrier. If we don't have that information, we might have to do a lab test on the fire stopping material. And then sort of step 4 is we're going to have to go to site to gather data. So before we do that, we need to make sure that the site is safe for us to do that. So we need to see, is there existing information around sort of asbestos risk if we're going to have to lift ceiling tiles and things like that, or do we need to go and do asbestos surveys and safety surveys on site? And then on to step 4 is we can utilize a range of different technologies to help us gather data on site. So point cloud scans, Alex mentioned, but there are also other useful technologies like 360-degree photographs are really useful. Just standard photography is really good. And there are these devices called confined spaces drones. So you can put drones into areas that to undertake photogrammetry and things like that as well. So here's some examples of what these technologies output. So at the top there, some nicer images of point cloud scans. The one at the bottom, not so great, but it's showing the hole in the fire compartmentation there, and the cable trays running through, which is exactly what we want to be picking up on the 3D scan. So this is an example of a 360-degree photograph. Really nice because it gives you that additional context that you don't get with a standard photograph. So you can kind of pan around and messed up this graphic. So I was trying to show here that there's obviously been a pipe that's been added in later. You can see going through a fire stopping material there, and you can see that the fire stopping material hasn't been filled back in. So that's a problem for that fire barrier. And then just a few example photographs here, just still photographs. You can just see sort of breaches in that compartmentation line that have occurred over time. And a few more examples of these here, and one more for good measure here. So, new pipes or ducts added in, and the gaps around them not being filled back in, or holes in fire stopping plasterboard there as well. So the next challenge, how do we then analyze this data? So within a recently constructed building, we should have design information. So we can do that fire stopping of the design model, which is what Alex has been talking about. And here you can see that kind of green rectangle, which represents the fire stopping material itself. The next thing what we need to do is be able to compare the as-built situation to the design information. So we've confirmed that the design information is okay, and that meets the distances and everything that we want to meet. But then what happens if it's installed in a different way? So in this 3D scan, you can see that the scanned pipes are in a different position to the pipes in the design model. So that would represent a potential problem. And then these are the kind of situations. So remodel and rerun the analysis if necessary. So we've got the design model on the left-hand side there, the green shapes representing different services running through, the white background being the fire stopping material. So in the as-built scenario, if everything is built exactly as designed, then we know it's fine because we've run the checks in design. If we have some very slight slight differences here. As long as the spacings are still fine, then again, we've got no problem. So we've got the green tick still there. The next situation, we're missing that fire stopping material. So we've got a gaping hole. So that clearly represents a problem. And then the final situation is the fire stopping material is in place, but the services have moved. And now the services are too close together. So again, we have an issue. Then the third challenge is how we maintain this building throughout its life cycle. So if we've modeled all of these fire stopping materials, what we can do is we can assign planned maintenance activities to go and check those on a regular basis. You can do this through a model viewer. You can do this through different CAFM platforms, computer-aided facilities management platforms. The great thing about the model viewer is you can click on the fire stopping materials. You can get access to the data that tells you, what they are, what you're expecting to see. So it would be a good idea to do something like this on a sort of five-yearly maintenance plan. What are the common failure points? So we've talked about things being designed incorrectly. Image on the left there. Things can be built incorrectly. So these two halves of the bridge not coming together. The buildings can be modified. So holes and things can be produced over time that aren't backfilled with fire stopping material. Regulations can change. Regulation changes aren't normally applied retrospectively, but if we're doing some changes to a building, we're probably expected to enact those to the most recent legislation. So that's one to consider. And then all materials degrade over time. So the right-hand side there, that's an asbestos roof tile, but you can imagine the same thing can apply to fire-stopping materials in the building. So over time, we need to keep checking that the fire-stopping material hasn't degraded. And then just a few points on record keeping and awareness. As buildings change over time, for example, we remove a wall here, we're changing that building situation. So think things like the egress, things like the fire stopping in that space, the sensing of smoke and things like that. All of those things need to be considered when a change happens, and we need to try and keep those records up to date. And then awareness being that when we're bringing contractors into the space to make changes, that they're aware of which walls are firewalls, they're aware of what's needed in terms of making sure that the wall is compliant when they leave it as when they started work. And then a few other things to consider around sort of room use and change. So if we're going to change the use of a space, even if we don't change any of the building services or anything else, we need to consider if we're going from like low density to high density, what that does about the means of escape and the egress. And then my final slide is what to do if the building layouts change themselves. So if we're dividing rooms or combining them, and we've got things to consider like records being attached to rooms. So if we don't have this 3D model situation and we don't have things like asbestos modeled and on plans, if we're just referring it to like a room number, do we now understand that that room is changed and that the asbestos might not be where we think it is anymore, so that sort of thing. And then how that changes the compartmentation and the occupancy requirements when we do works to buildings. So that's me, and I'll pass over to Simon Gilbert now.
Fantastic. Thank you, everybody, you guys, for doing that presentation. Really insightful. As you say, we're going to pass over to Simon Gilbert now. So I'm just going to make you a presenter, Simon, if you're there.
Okay, thank you. Okay, thank you very much, Mike and Brent and Alex for highlighting some of the challenges that we face with obviously existing buildings and also new build around fire stopping in the industry at the moment. So the presentation today from Solibri point of view, bear in mind that everything we show is work in progress, so we'll take it from there. I'm Simon Gilbert. I'm the Technical Services Manager for Solibri. I'm responsible for some of these projects like we're looking at today, really. I just wanted to highlight with the presentation, really, sort of a journey for the users from a maturity point of view of what Solibri is really about. So a lot of our users come to us with just actually the ability to open models. So this is sort of getting started with Solibri. concentrating things on model-based workflows, federating, and then using sort of the default contents that we have out of the box, basically, to do things like clash detection, which is one of our rule templates. But obviously you very quickly move to the point where you want to get the most out of Solibri, and to do that, it's a case of then looking at creating classifications which enable us to, filter sets of objects and visualize them in different ways, and creating custom rule sets. So when we mean custom rule sets, we mean that we have a set of templates. The clash detection rule basically is one of those rule templates, and we have over 50 of those in the box that you can configure to do all manner of things, from data checking through to egress analysis, through to free area in front of components and distance between elements. So all those different types, and right down to sort of spatial checks as well. So there's a lot in there that you can customize to actually improve sort of your model's Q&A. Obviously, custom ITOs for then the reporting information as well. And then we move into sort of the automation sort of side of it. So once you do have that functionality set up where you can actually, you've got your own rules and versions of those rules, then you can use things like auto run to automate some of that process. So the next stage really on from that is really to use the software development platform, and the software development platform gives us access to the API, which gives us functionality with all the features within Solibri, and gives us the ability to customize and create our own sort of automated sort of workflows. One of those being creating new rule templates, and this is sort of the starting point for today. So we're looking at Firestopping, and I've had a number of contractors that have obviously approached me saying that they needed this functionality within Solibri. And although we can do quite a lot of distance commands and checking, as you can see, that Ridge and Partners have done a really absolutely fantastic job doing that. What we wanted to do is create something that was very specific for Firestopping as a rule template. It's work in progress, as in I only just got a very first sort of version of this yesterday. So and it is only at a very rudimentary level at the moment. So we've had a meeting with a number of contractors and Ridge, and we've gone through the requirements that we deem necessary. So a major sort of document that we've used in the preparation of this information is this Firestopping of service penetrations from the Association of Specialist Fire Protection and BISA, BISRIA, FIS and GPDA. And what that really highlights is that we needed to concentrate the new rule template to address the sort of golden rules, which were golden rules 3 and 4. And that was to do a identification of service intersections with those compartmentation walls, and look at the key spatial requirements for those services, i.e. the distances between each of the services and the openings themselves, or the fire seals as we're looking at them. So that was sort of like the basic outline. As part of that meeting, we identified that it needed to support different stages of the project where certain data may or may not exist at those relevant stages. So the first stage was actually to take a model and be able to identify the intersections of those services through those fire compartment walls and floors, and do just a very basic sort of minimum distance checks between the services, and being able to do that via Excel, or be able to import a sheet to be able to do that kind of data sort of checking. When the project moves on, we may have a situation where the fire seals have been modeled, or the fire stopping objects have been modeled, and in which case then we would then be able to check to the distance requirements within that seal on its own, to the edges of the fire seal itself, and the distance between those different fire seals in the same compartment wall and floors. But obviously, at this particular stage, they may not be manufacturer-based conditions. What we'd like to be able to do is manipulate those sheets. Some of the challenges of the test conditions, basically from the different manufacturers don't always conform to a standard. So that will be a job to try and see if we can automate some of those imports of the data from people like Rockwell, Hilti, and other providers, really. And we're going to group those results based upon the fire seal themselves, i.e. what services go through that fire seal. Then, if the fire seals or the fire stops have been actually modelled in the model, we need to ensure that the builder's work holes that may also exist or have been punched in from the structural and the architectural models actually conform, and they're exactly the same match for match of the fire seal. So there's a sort of a comparison or coordination between those two objects to ensure that they are coordinated. And again, as Alex pointed quite clearly, it's an iterative process, and at any point in time, then being able to grab a report, so collect all the fire seals that are in the model, and then indicate and collect all the information from the fire seals and the supporting construction that the data is actually so for the fire seal is sitting in, so we can pull all this data out which relates to it. So this involves us not only just doing what we could do inside Solibri, which is a sort of clash detection, but also linking that clash detection with the intersecting volumes and then checking the distances in one rule rather than creating multiple rules. So without further ado, I'll move over to Solibri, the application, and I'd just like to thank, first of all, Langerock here for providing us a very, very basic model just to be able to test some of these conditions. So thank you then again. Another item that Alex really pointed out, which was absolutely critical, is that we can't do any of this without consistent data and information that we can actually hook into to actually check these conditions. So having a well-defined definition on the project is really important. So what we have here is the ability to classify using the classification system fire seals. And in this case here, it shows us the fire seals that are in the model or the fire stops or whatever. So terminology needs to be set as well, but the idea is that we'll create a classification which highlights those objects. Now, at the moment, we've only got one here, but they could be the test cases basically that have been generated. We also have here the service classification, which actually identifies all the services within the building. And at this moment, we've only broken it down to the key kind of elements, but you could actually have pipes and their relative sizes, basically, just a more granular based classification to do that. So these are going to feed into the rule in order for us to actually select that. But obviously, we need to know, obviously, from a fire compartmentation part of the walls and the floors that should be included. So if I go back to the checking area now, we look at the fire stopping rule we have actually here. The first part of the fire stopping rule gives us the ability to specify the compartmentation, so the walls and the floors that actually should be included. Now, in this case here, we've just included any of them because it's an example file, but you may have to either create a classification or select those elements via the parameters that are needed. The services basically will take any of the services from the model, so we need to indicate which services are going to go through to that. And then we have the ability to use this service classification basically, which we'll use for the distances and the data between those elements. Now, this rule has two sort of levels. So it has the check within a fire seal. So if the fire seals have been modeled, we can activate this function. If we don't do that, then it will just be using the service classification and the data within the requirements path down here. Once we are indicating that the fire seals are modeled in the project, then we can then use the classification for that as well. All we do with the requirements path is we put in the Excel spreadsheet, which is going to drive the functionality as far as the distances. And if I were to go over to the Excel spreadsheet, it's very, very simple here. So in this case here, we've got our service distance and we've got the source service service type against the target service type. And the whole idea here is that we could have cable carrier against all elements, or we could have ducts against whatever, or so we can extend this list and import the list in. I see the challenge will be to try and emulate the requirements based upon what's in the manufacturer data. Now, I've put in the distance, so at the early stages, what we were just trying to do is just do a very quick check of if a service actually clashes with the walls, then is there a, is the standard dimension between those services that needs to be sort of adhered to. And I've put 300 in here because the fact that the model is quite well modeled anyway. So if we put 50 in here, then everything would pass basically. So I'm just going to show it at 300 first of all. And then we have the fire seal information, which is all about, so we would have our test cases down here, and then we'd actually specify what the distance are between the different seals and the distances between the services and the fire seal edge for this type of service. So this is going to drive the functionality in the software. So if we go back to Solibri and we've run these conditions, what we're looking at in here is that what we've got is the different services which are non-conforming as far as their distances. So we put 300 in, and it's telling us they're within these relevant distances in the model. So straight away we can go through any of these objects and start looking at the relevant distances in the model itself. If we change the data in the spreadsheet, so if we go back to the service distance and we change this to say 50 mil, resave the file, we have to instigate the change in the rule by activating some parameter basically. We'll recheck it, and then I'll go back to the I'll turn that back off again. It's just that you'd have these set up with the relevant conditions. Once this is run through now, you'll see that we've only got 2 results here. So we've got distances that are unsatisfied, these ones here, which is obviously the components are sitting outside of this fire damper outside of the seal. And then we've got these services that are unclassified. So what we've done here is we're identifying services that really should have probably have made the classification, and highlighting ones that may have been missed from the list of services from the classification. So that would be the early stages, as in the stages like where they might not have fire seals in the model. If we activate the rule and we go down and actually tick the service distance to the fire seal now, then it's going to use that extra page on the sheet. And if we recheck the model now, what we're now looking at is the different results in the model, and it's going away and checking those different kinds of conditions. So first of all, we're checking the distances between those fire seals to make sure their adjacencies and everything else are conforming to the value we put in the sheet, which was 300 mil. And we're seeing here that they're obviously, this one's 179 millimeters away. So again, it's giving us this data in the model. Let me just double click, and you show again, we're seeing the same kind of information between the fire seals. And then if we look at some of the services in the model, let's just go to one of these ladders here. You can see that we're now checking the distance to the outside value where we put in 50 millimeters. So you can see 27.5 here. It's to the outside edge of those fire seals. So the idea is that, again, it's work in progress. We will do a lot more work on this, and hopefully make it available to users relatively soon. But we'll keep working with the teams, with Ridge and the other contractors, to make sure this delivers what those people actually want, and hopefully then it will make will be applicable to everybody. So, but okay, thank you very much for the time and the ability to show this this part of Solibri.
Brilliant, thank you, Simon. I'm just going to move my screen back to myself just to sort of summarize what you've seen on screen just now. So let me just share my screen. Hopefully you can all see that okay. So again, just a big thank you to both Ridge and Partners for your presentation, and obviously to Simon as well for what you've done. And what I just wanted to quickly do, we've got a poll question at the end. So if you want to share your engagement on what you've seen, feel free to hold on for that. But in a summary, some of the highlighted sort of benefits of this new fire stopping functionality, and Simon showcased your sort of maturity of users and your growth and journey with our software, is to unlock the benefits of the API with Solibri there. These new rule set templates, they allow infinite possibilities for where we're going and what we define and what we do, and how we engage with you to build these sorts of rule sets. What you've seen on screen provides a deeper and more intelligent workflow for checking when it comes to fire stopping in particular, intelligently combining both clash and distance-based demands. And although a bit of a caveat. Although this does require sort of Java programming skills, Solibri and our partners are actually able to provide and offer this service to you. So if you do want to have this conversation with us about configuring and setting up what you've seen on the screen, then do get in touch with us, because it'd be we welcome anybody to join this journey and have a really good involvement and partake in what's happening and what's changing within the software for you. But as I'm sure you're aware, the benefits are quite incredible for sorry, lost my screen, to the industry to support the compliance with fire stopping, which is a complex challenge, which I'm sure you're aware of, which involves huge risk, rework on site, those unplanned costs and frustration, and that's exactly what we're tackling head on. So for those of you that are maintained Solibri Office customers, whether you've got a network license, a single user subscription license, or even e-commerce subscription, or perhaps you've already got the brand new team subscription license that we've recently released for Solibri Office, this sort of functionality and this engagement with us is available to all of you. So a big thank you again. I'm just going to pop a quick poll question on the screen for those of you that wouldn't mind engaging on this, and we'll move on to answering some of your questions. So hopefully you can all see that okay in just a moment. Perfect. I'll leave this on the screen for another 30 seconds or so. And what would be really good to see is that your feedback for this poll is hopefully that everything you've seen is relatable, and if we can take this conversation offline with those that is of interest, then let's keep that conversation going. So another 10 or 15 seconds and I'll close the poll. Okay, fantastic. Well, interestingly enough, I'll share the results with you as well, just so you can get a general consensus of how common these challenges are. So all the time, sometimes, big portion of you are having difficulties with this type of workflow. So let us know, get in touch with us. We'll more than happily collaborate with you and discuss the future of Solibri and what we are doing to take this challenge head on. So really good to see that feedback, so thank you. And I suppose the follow-up poll question I might have with you is something along the lines of, do you want our support? And if you do, then let us know. And this might be an opportunity here just for me to drop you an email after the fact and get in touch with you, save you the hassle of having to do it. So feel free to answer this poll question as well. Just give you another 10, 15 seconds as well. Few more seconds. Okay, fantastic. So well, I'll share the results with you. So as you can see, the majority of you there are wanting me to follow up with you and help to support you with this this too. So fantastic. Well, thank you very much for everybody for doing that for me. What we're just going to do is take a couple of minutes now just to answer some of these questions. You'll see the contacts on screen. If you want to follow us on our social media pages, add me in the middle. If you want to scan these QR codes on your phone, my contact details will populate in your contact book, so you've got my details on hand. But let's have a look at some of these questions. So if you guys from Ridge and Simon, you're still there for me just to answer some of these, that would be perfect. I shall read them out and we'll take it first come, first serve. So first question, does fire stopping perish or become inactive over a set period of time? And if so, does this tool enable tracking? Does the tool enable scheduling or periodic inspection requirements for building owners?
Great question. And I'm not convinced I know the answer to any of these. I don't know that they do perish, but I believe they do need to be routinely inspected to make sure that they're still in place and they haven't fallen out. The bigger issue is when a client organization might instruct some work, and if the information isn't known about the performance of that wall or what the product is in the wall, then if that product needs to be reinstated because it's been damaged through being uninstalled, then clearly, it's the data that the client needs to understand what product goes back in. So the tool won't necessarily help with understanding when, if it's going to perish, but it might give you a design life figure, for instance, on that product, and it'll definitely give a steer as to where you can get that product from again if needs be.
Yeah, the main point I was sort of trying to highlight there is just having those as assets modeled in the model means that you can then have those like periodic PPM activities to go and inspect. And like Brent said, the main cause of damage to Firestop is going to be where you've done sort of maintenance work, run new services, and not really considered the fire stopping. But materials can degrade over time, and buildings can settle, and you can get cracks appearing and things like that. So it's good to also have a regular inspection for those issues as well.
Perfect, thank you. We'll fly through some of these. There are a lot, so we're probably not going to be able to get through all of them, but we'll get through 2 or 3 more, and then we'll see where we go. So are there any codes, standards, legislation currently or in progress that would drive the need for this digital recording of information for buildings?
I think the Hackett report points at, makes recommendations like the golden thread for using the principles of a BIM process to deliver digital information to a client that they need to maintain throughout the life of a building. So whilst that's not legislation, that has gone on to drive things like the Building Safety Bill, which are coming into effect and are going to drive the requirement for this on some projects. So I think that's the key kind of outcome from this, I think.
Yeah, and that bill's still in draft format at the moment, so we can't be entirely sure what it's going to say, but it's likely that it's going to sort of say that we need to keep a handle on the building information, so we understand sort of retrospectively what's been done in the past to the building, and it's probably also going to sort of make some advisory notices around that sort of thing.
Mm-hmm. Excellent. Okay, great. Well, we'll just take 2 more. So here's one. So the information shared is in relation to precast walls and blockwork walls. Has this been implemented for stud walls?
Yes, because it's just different bits of the same test data. So it would have been tested in different types of opening.
Okay, thank you. And we'll take 1 more, and then any other questions that we haven't had the chance to answer, I will ensure that we follow up with you, to anyone that's asked those questions. So you will get answers to those questions, I can assure you. So let's just take 1 more. What about addressing the need of an industry-wide or perhaps global unique product identifier to ensure digitalized transactions can be fully supported?
It sounds like the right approach. I must admit that's probably a question better placed for Simon or Alex, I think. But to me that sounds like a really good method of making sure that information is passed from different parts of the supply chain and ultimately onto the client. But yeah, it'd be interesting to see what developments in that space come in the next few years.
Excellent. Okay. If you guys got anything else you'd like to add to the questions at all, if not, then I suppose that's everything.
Thank you, Isaac.
Perfect. Well, thanks everybody again, Brent, Alex, and Mike and Simon for joining us and presenting. It's really insightful. This recording will go out to all of those that have registered for this webinar. So thank you as well to all of you attendees for joining us, and we hope to see you again very soon for the amount of webinars that we've got lined up. So please feel free to watch our social media and get in touch with us if you have any further questions. But otherwise, thanks again.